So support for 7A, this one's decimals and fractions. If you have your graphing calculator, I mean, we all know how to reduce 2/4, or I think we do. If you've got 2/4, you would want to say, well, what goes into 2 that also goes into 4? And so you would divide the top. You would say, well, 2 will go into both of those. So you could divide the top and the bottom by 2, which would give you 1/2. Okay. But the calculator does this for us. So if you've got that graphing calculator, I would definitely use that. So like on the next one, I'm not going to work all of these like this, but if we have 6/15, you're going to have to be able to kind of recognize what number goes into both of those, the biggest number. And I think it's 3. So that's going to be 6 divided by 3 is 2. 15 divided by 3 is 5, which is 2/5. If I go to my graphing calculator and I want it to do the work for me, let's see. Okay. So I'm going to clear out this screen and I'm doing alpha y equals to get the fraction to come up, and then I can hit enter, and then we just do 6, right? Type in our fraction, 6/15, and then hit enter, and it tells you that it is 2/5. So I just went to alpha y equals, hit enter to type in 6/15, and then hit enter, and then it tells me that it's 2/5. So we can use the graphing calculator to kind of alpha y equals, and y equals is a, yes, and then just hit enter, and then you're going to type the 6/15 in and hit enter, and it'll reduce the fraction for you. Yeah. So on the next one, I think the next one is 5/10. So I'm just going to stay on this calc. I mean, we know that that's 1/2, but just to practice alpha y equals, we've got 5, and then arrow down to hit over 10. Hit enter. It's going to tell us it's 1/2. I'm going to keep going through these. The next one, our example is, so we don't have to go back and forth and back and forth. We've got 35/45. That's 7/9. And then the last one is 13/65, which that one would be really hard to figure out what goes into third. I mean, not really hard, but more difficult. To figure out what goes into 13 that also goes into 65. So it kind of just helps you. (13/65). Okay, and so I got 1/5 for that one. Another thing that this calculator will do, okay, so let's go down and look at number 6. On which one?
Oh, never mind.
Oh, that's okay. So another thing that you can do is you can just divide these. So like on number 6, it's, I don't think this is the easiest way, but I want to point out that the calculator will do this. If we do 1925 divided by 3,960, I just typed that in. 19, so this is number 6. Instead of doing alpha y equals, I just typed it in as a division problem. 1925/3920, or divided by 3920, and I should have put 20, not 60. Sorry. Okay, and then I'm going to hit enter. Now it gives me the answer as a decimal, but we don't want that, right? And so what we could do is if you hit math, the math button, this thing will say, well, number 1 says, well, turn it into a fraction for me if it'll go. And number 2 says, turn it into a decimal if it'll go. So you can go back and forth. So if you have a fraction and you want a decimal, you would hit number 2. And if you have a decimal and you want a fraction, you would hit number 1. And we do want a fraction so we can type our answer in. And it turns it back to 55/112 for me. So I just hit math, and then I hit enter. So it would I had a decimal when I divided and I wanted a fraction. So if you want to go back and forth between decimals and fractions, you can use that math button and it will do that for you.
Well, it said for me it's the answer.
Did you type in 1925 divided by 3920? You got to type that in first. Then hit enter and it's going to give you a decimal. Then you hit the math, enter, because you're turning this decimal into a fraction.
There we go, okay.
Okay, there we go. So, and then just to make sure you know that if you hit alpha y equals this, and you want, let's say, we want a mixed number like 2 1/3. If you arrow down to 2, okay, that will let you type in your mixed number, 2 1/3. Okay, but let's say we won't want it like that. We want it to be a improper fraction. So it's not a mixed number, like I call it top heavy if it's an improper fraction. If you hit alpha y equals again and pick number 3, hold on a minute. I did the wrong thing. Maybe it does not go back and forth on this one. I know it does somewhere. So I think it will go the other way. So this is 2 1/3 is 8/3. I mean 7/3 because 3 times 2 is 6 plus 1 is 7. So it will go backwards. I know it will do that. So if I do alpha y equals and I type in enter and I type in 7/3, well that fraction's improper. So if I want it to be proper, I can type in alpha y equals and now go down to 3 and hit enter and it'll turn it to that 2 1/3 for me. So if I've got an improper fraction and I want a mixed fraction, it'll do that for me. You'll also notice on alpha y equals that other button's there, fraction to decimal. That's there. So you can use that from this screen, or you can use it at the math button like we did a while ago. It doesn't matter. Okay, so let's go back. Finish this real quick. So we worked them with the calculator. I always want to make sure you know how to do it the other way as well. But we're reducing 5/10. I know that 5 will go into the top and the bottom, and that's going to give me 1/2. We're 35 over 45. We could divide the top and the bottom of that one by 5 as well. That's going to give me 7 over 9, which we already came up with on the calculator on these. 13 over 65. We can divide the top by 13 and the bottom by 13. That's going to give me 1/5. And then on this last one, okay, it would be kind of difficult to figure out the biggest thing that's going to go into both of those, which is one of the reasons why you want to have the calculator to do that. But when I was doing this by hand and not using the calculator, I'm recognizing that this ends in a 5 and that ends in a 0. So I know that 5 will go into both of them. So I had to start somewhere. And 1925 divided by 5 is 385. And 3920 divided by 5 is 784. Well, I needed to find something else that would go into both of them, and that was difficult. So I had to just play. I just had, like, if I was doing this by hand, I had to kind of play with it. I knew 2 wasn't going to go because this is odd. An odd number, so 2 won't go. You could try 3 you could try the, just go try 4 and see if it'll divide into both of them. It took me till I got to 7 before I could get another number that would divide into both of them. And that got me 55 over 112, which was the answer. So it's nice to have that button on the calculator that'll kind of do that for you so you don't waste your time. Divide out, right? I think we've talked about rounding before, but if you are asked to round something, we know that we've got place values, right? This is our decimal place. And then, so this is our ones place. If we were going to write down a number, this would be the ones place. This place that's on the other side of the decimal, it's kind of weird, but when we go backwards, we're starting with the tenths place, not the ones place. The next one is going to be the hundredths. That's not how you spell that, sorry. I'm trying to write crooked too, so yeah. Hundredths place, and then, so that's that place. And then we would have the thousandths, and these end in THs, which is kind of weird. And then the next one would be 10 thousandths, and I don't think that you guys are asked anything after this, but these are the numbers, when we're talking about rounding, that's what we kind of want to look at. So on problem number 7, it says round to the nearest tenth, and our number is 4.7691. So 4.7691, and it said to round to the tenths place. So that means I'm going to go and acknowledge that the 7 is in the tenths place. So I have to stop there. So you're going to look next door. I have some visitors outside. Hold on 1 minute. Just leave my office door open. Okay. Sorry about that. So we're going to look at the 6 next door, which is bigger than 5, right? If it's 5 or bigger, it makes this number round up. So this is going to be 4.8. It said to round to the tenths place. Does that make sense? So 4.8. This one says to round to the nearest hundredths place. Okay, so 0.776. The hundredths place would be the second decimal place right here. So that's the one I know that I need to stop at. I can't have anything past the hundredths place. So I'm going to circle that. I'm going to look next door. That's a 5 or bigger. So I have to round the 7 up to an 8. So my answer would be 0.78 on that one. The next one says also to round to the nearest hundredth, and we've got 0.4001, 0.4011. It's 4011. Still, they want us to round to the hundredths place, so I'm going to circle that one. So I know I can't go past this. I'm going to look next door. This is not a 5 or bigger, so that means it just stays 0.40. Okay, 27.7582. Can I write that down right? No, 7582. And they wanted this one rounded to the thousandths place. So now we're going down to this third position. That's the one we want to circle. Look at the number next door. If it's not 5 or bigger, it stays the same. So this is going to be 27.758. Okay, we're good with that. Okay, you're okay with rounding stuff? Super fabulous. An experiment consists of drawing one card from a standard 52 card deck. What is the probability of drawing a 4? Well, there's only in a 52 card deck, if we're just drawing one of them, okay, what do we know? We know that we've got 4 cards that are 4s, right? We've got the spades and the jack and the, what else? Hearts and the clubs. So there's actually 4 of these cards in the deck. So there's 4 out of 52 chances. Now they want us to simplify that fraction. Okay, so they want us to simplify that fraction. Now we can go to our calculator and reduce it just like we did a while ago. Or we can recognize the fact that we could divide out. So I'm just going to do alpha y equals, hit enter, 4 over 52, and it says it's 1/13, which kind of makes sense if you know anything about cards because they're divided into groups of 13. You've got your clubs has 13 cards, including the jack and your spades and all of that stuff, right? So it makes sense that we have that this is equal to 1 out of 13, and that's the answer. So number 12, last one on this support says, suppose that an urn contains 4 yellow marbles, 6 green marbles, and 10 black marbles. Well, the first thing I want to do is figure out, well, how many marbles is that? So I've got 4 yellow, I've got 6 green, I've got 10 black. If we add all that up, we have a total of 20 marbles. Add all that up, we've got a total of 20 marbles. And the question says, if one marble is selected, determine the probability that it is yellow. Well, the yellow ones are 4, so it would be 4 out of 20. And we would want to reduce that fraction. And that fraction, 4 out of 20, can reduce to, we can go to our graphing calculator to do that, but it's going to be 1/5 because 4 will go into 4 one time, 4 will go into 25 times. So this is what you would want to put. That's going to be your probability. Okay, we good with that? The math button will change it from a decimal to a fraction and from a fraction to a decimal. Like if you have a decimal and you need a fraction, or if you have a fraction and you need a decimal. Okay, let me get the support 2 up. Okay. So it's going to go a little bit quicker. I'm not going to probably go back and forth for the graphing calculator on this one, but it says choose the best answer to the following question. Explain your reasoning with 1 or more complete sentences, which they've kind of done for us. It says, suppose that 4 6-sided dice are tossed. How many outcomes are possible? Okay, well, the correct answer is B. Because every every dice or every dice has 6 sides, right? So this represents one of the dice. This is another dice, another one. These would be all 4 of them, and they all have 6 possibilities on each one of them. And this is the reason. So it would be 6 times 6 times 6 times 6 because each of the 4 dice have 6 outcomes. Okay, does that make sense? That's why we would want to pick that. So number 2, license plates in a particular state display 3 letters. Right, so we've got a license plate, and the first 3 spots are letters. This letter, this letter, this letter. The last 3 spots are going to be numbers. Okay, so it says how many different license plates can be manufactured for this state? Well, we got to think about how many choices can go in each spot. Okay, so how many choices can go in each spot? Well, how many letters are in the alphabet? Been a long time since we had to know that, right? 26, right? There's 20. Yeah, it's been a long time since we had to do that. There's 26 letters in the alphabet. Now, in this spot, if it had said, well, you can't choose the same letter twice, right? Then we would have had to make this spot be 25, but there's nothing that tells us this. In other words, we could have, this could be an A, this could be an A, this could be an A. So we still have 26 choices for this. We still have 26 choices for that spot. Now, when we talk about numbers, right, you've got your 1, 2, 3, 4, 5, 6, 7, 8, 9, but you also have 0. So that's your 10 numbers that can go in each one of these spots. So to find this answer, you're going to have to multiply your options. So 26 times 26 times 26 times 10 times 10 times 10, which is a really big number. Okay, so 17,576,000 different options that we would have for license plates. So if you had a state that had over that many people, you might have some issues, right? Over 17 million, but that's not going to happen very much. So, and they would all have to be drivers and all have to have a car. So, okay. Number 3, use the theoretical method to determine the probability of the event given below. The theoretical method sounds complicated, but all it means is, what do you think it's going to be? Like if you have to make a prediction, the theoretical method is, well, what do you think it's going to be? So it says rolling a die and getting an outcome that is less than 4. Well, we know that if we have a dice that it's going to have the numbers 1 or dots on it, I'm sorry, but we'll have 1 dot on one side, 2 on the other side, 3 dots on the other side, 4, 5, 6 dots, if we listed all the sides, okay? So if they want to know what's the probability that I'm going to get something that is less than 4, well, how many of these things are less than 4, right? This one's less than 4, this one's less than 4. So 3 out of the total, which would be 6, is less than 4. If we reduce that fraction, that would be 1/2, which is what you're going to have to do in the end. So we have basically a 50% chance, 50% chance that we're going to roll less than a 4, which makes sense, right? On your paper, if you've got the hard copy, it's really difficult to read these. On this is a little bit clearer, but it says, number 4 says, use the spinner shown to answer the question. Assume that it is equally probable that the pointer will land on one of the colored regions. If the pointer lands on a borderline, spin again. So if the spinner is spin once, find the probability that the pointer lands in a green region. Well, I'm gonna have to know how many regions, they're equally divided up, right? Each little section is taking up about the same amount of space. So I've got 8 sections here. So we've got 8 total. How many are green? And it's very hard to see on your paper, I know that. It looks like 2. This one is green right here, and this one is green right here. So 2 out of 8. I'm going to color these in real quick. This one is blue. This one is blue. Supposed to be blue. We have red, and this one across from it's also red. And then we have yellow, yellow. Okay, so we only have 2 out of 8 that are green. If we reduce that fraction, it's going to be, because 2 can go into both of those things, it's going to be 1/4. All right, 2/8 is just 1/4. Suppose that an urn contains 3 black marbles, 8 yellow marbles, and 9 green marbles. If one marble is selected, determine the probability that it is green. We're going to need to add up the 3 and the 8 and the 9, which is going to be 20. We've got 20 total marbles, so whatever our fraction is going to be out of 20. And what they want to know, the probability that it's going to be green, well, it says that there are 9 green marbles, so 9 out of 20 are green. That fraction, there's nothing that will go into 9 that'll also go into 20, so that you're done. It doesn't reduce any more than that. Number 6. A 6-sided die is rolled. Find the probability of rolling an odd number. The set of equally likely outcomes is shown below. So basically they're saying you can roll a 1, 2, 3, 4, 5, and 6. And we know an odd number is a number that is not divisible by 2, right? So 1, 3, and 5 would be odd. 2, 4, and 6 are even of those choices. So these 1, 3, and 5. So I have a 3 out of 6 chance of rolling an odd number, which is just 1/2. 3 out of 6, which is just 1/2. Okay. Number 7. A fair coin is tossed 3 times in succession. So they're kind of giving you every possibility that you have right here. So the first time you could toss, I'm gonna scoot down and explain this a little bit better. So the first time that we toss the 3 coins, we could get a heads on the first coin, a heads on the second coin, and a heads on the third coin. The second time that we toss them, it's possible to get heads on the first 2, tails on the last 2. The third time I could get a heads, tails, heads. So they've just gone through and basically listed every single possibility. You could get a tails and a heads and a heads. You could get heads, tails, tails out of your 3 coins. Tails, heads, tails. Tails, tails, heads. And or they could all be tails, right? It's possible. So those are all the outcomes that you could get. Another way to do this, like if you have trouble, like sometimes thinking of all the possible outcomes, because you can't work these problems if you can't think of everything that can happen. So you know your first coin is either heads or it's tails. So this is the first coin, right? Our second toss, our second coin could be a heads or a tails. And then for our third coin, for each one of these, it could be heads or tails, heads or tails. heads, or tails. So if you follow if you follow the lines, this one would be a heads, 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 which is our first choice right here, right? If you follow this one, we would have heads, heads, tails, because you're gonna have to hit every single one of them. That would be heads, heads, tails. Well, that took care of all the options on that. Number 3 would be heads, tails, heads. Number 4 would be heads, tails, tails. Number 5, tails, heads, heads. So this is kind of a way to organize your thoughts, because if you're like me, I would have a hard time like coming up with these 8 possibilities in my brain, because I would be like, where do I go next? Tails, heads, tails. And number 7, tails, tails, heads. And then the last one is just tails, tails, tails. And it doesn't matter what order they're in, but that's the 8 possibilities, right? That you could, if you have 3 coins, that's what could happen, okay? So the problem says the probability of getting just one head when you flipped them. Well, so we know already that we're picking something that's out of 8 because there's 8 things here. So if we just want one head, well, this one has 3, this one has 2, this one has 2, this one has 1, right? So that one would count. This one has 2, this one has 1, this one would count. It looks like I've listed that one twice. That is, yeah, it should be, this one should be tails, tails, heads. Got going too fast. This one needs to be, did I make tails, tails, heads? Yeah. So this. Sorry about that. Okay. So this one also has one head then, right? Have we listed that one before? No. But we got this one. And then this one has no head, so that's not going to count. So out of the 8, there are 3 that have one head. So 3 out of 8. And you can't reduce that. You would try to reduce it if you could, but you can't. There's nothing that goes into 3 that also goes into 8. Okay. In class, I work this problem as if order mattered. And this problem does not say that order matters, so I need to fix that. In other words, I worked it as if the girl would be born first, and then the 3 boys would be born next. So we need to back up and look at this problem again. So let's talk about the first child. Okay, the first child could either be a girl or a boy. When we move to the second child, they could be a girl or a boy. So kind of working this similar to how we did the coin problem. But each one of these would have girl, boy for each one of these. And by the time we get to the fourth one, we're really having to spread out. So there would be a total of 16 selections. Let me go down this way for each one of these. So we could do girl, boy, okay, so when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, we're still out of 16 here. But what we're going to focus on is how many of them are 1G and 3B. So when we look at the list, we've got G, 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 G. Well, that's got 4 G's. We want 1G and 3 B's. G, G, that's already too many. We only want one girl. One girl, one boy, one girl, one girl. So I'm following these lists. So one girl, one boy, one girl, one girl. That's too many girls. Girl, boy, girl. Still too many. Girl, boy, boy, girl. Too many. Girl, boy, boy, boy. There's one. Okay, so I'm going to go kind of right over that with a different color so you can see it. So this option right here where we have a girl, a boy, a boy, a boy, that one is going to be one that we're looking for. And now I'm going to move down to this group. We've got boy, girl, girl, too many. Boy, girl, girl, boy. Okay, so that's still too many girls. Boy, girl, boy, girl. Boy, girl, boy, boy. There's one. That set right there only has one girl. So there's another one that works. Boy, boy, girl, girl. There's two girls there, so no. Boy, boy, girl, boy. That one would also work. This little chain, because this is only one girl. Boy, 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 girl. That one works. And then the last one has a girl at the end. Boy, boy. This needs to be a boy. And I need to write it in blue. So that would be all boys and no girls. So that's not going to work. So we ended up with, at the end, we had this, this row had one girl and all boys. This one has one girl and all boys. This one also has one girl and all boys. So does this one. So we've got 4 out of 16, which reduces to 1/4. Okay, so if order doesn't matter, it's going to be 1/4. If order matters, it's going to be 1/16 like we did before. If it matters, if you have a girl first, then all boys. And in this problem, they did not tell us the order mattered. So that's the end of support for 7A.